So what is physics? When we study physics, what we are doing actually? When we study physics, we are doing measurements. Most of the time, when we study physics, we are trying to understand something, how it changes its position, its velocity, its energy, and so on and so forth with time. So physics is about measurements. What we see here in this first slide, I will put the PowerPoint on the screen. Okay, what we see here is numbers. The speed limit is 50 miles per hour, which is the same as 80 kilometers per hour. As you can see, we are talking about a speed represented by a number and by a unit. The number is 80, the unit is kilometer per hour. This is using metric units, or this is equivalent to 50 miles per hour. This is just an example of physics. So usually we try to understand things around us, we try to measure it and to express the measurement using numbers and units. This is a summary of physics. This is what we do in physics. Few questions that should help us to understand this game. Which of the following would serve as the best time standard? So when we talk about quantities in physics and measurements, we need to use units that are agreed upon by everyone in advance. When I say kilometer per hour, when I say 1 hour, everyone understands what I'm talking about. I am using standards. Mile is a standard of length. Kilometer is a standard of length. Hour is a standard of time, and so on and so forth. So for any unit to be accepted, it has to be known and it has to be agreed upon in advance among all people in the world. Now, with this in our background, let's go to this first question. Which of the following would serve as the best time standard? The rotation of Earth on its axis, the vibration of a cesium-133 atom, a grandfather clock, the buzzing of mosquito. Each one of these represents some time period. But in order to use one of them as a standard, it has to be fixed. It has to be reproducible. Whether you did the measurement here or whether you did it in another country, in another planet, it has to be the same. So this does not apply to a grandfather clock. It doesn't apply to a buzzing of a mosquito. The rotation of Earth on its axis, this also changes, depends on where do we stand on Earth. The one unit that is fixed wherever we are is this one, number 2. The vibration of a cesium-133 atom, this is fixed. No matter where you try to check on the period for this vibration, it will always be the same. So we use this as a reference when we measure time. Then another example for measurement. Suppose that you measure the position of a chair using a meter stick and you record the distance of the center of the seat from the wall. Which of the following measurements is the most reasonable? 1.043860564 meters. This is impossible. Using a meter stick has dashes on it, is graded with centimeters, with millimeters, but it cannot give you that kind of precision. The same applies here. Then for number 3, 1 meter. Yeah, with a meter stick we can do better than that. 1.04 meter. I will choose this one. Yes, with a meter stick you can measure centimeters. So this is 4 centimeters. Therefore, this would be a more reasonable number using this kind of instrument. So each situation, when you do a measurement, has its own limitation that we need to recognize and understand in advance in order to do a good work.